Okay, so I think we should be live. Let me just quickly check if we are actually live. Can you type in yes if I'm audible and if you can see the screen, etc.? Hello, hi Arjun. Okay, so yeah, I think others will also start joining very quickly. So how are you? How are you, Arjun, and others who have joined in? Yeah, this was the problem again related to graph, just like yesterday's problem, right? So this is today's lead code problem. So let's just go through the problem, start going through the problem. Meanwhile, others can quickly join in as and when they find the link, right? So, okay, let's go ahead. So let's look at the problem. It says that you are first of all given an integer n, right? That is the number of courses that are there, and they are numbered from 1 to n. So we have n courses essentially. Now, some of the courses have a relation between them, which is that one of the course is a prerequisite to the other course. So if we look at relations array, here 1 3, then 1 is a prerequisite to course number 3. Similarly, if we look at 2 comma 3, 2 is a prerequisite to 3. So if we look at it the graph way, in a way 3 is dependent upon both 1 and 2. So I'm not sure if this edge is visible or not in this dark mode, but in the light mode you'll be clearly able to see that there is an edge from 1 to 3 and 2 to 3. So apart from relations, you are also given time, that is the time taken to complete one particular course in months. So for example, to complete course number 1, I'll be using up in a way 3 months. To complete course number 2, 2 months. To complete course number 3, 5 months. So basically what is given is there are some courses, every course has a time to complete. Every course also has some prerequisite courses. So for example, here 3 has a prerequisite of both 1 and 2. So 3 can only be started when both 1 and 2 have been completed. So the first condition, if we look at it, it says you may start any course if the prerequisites are met. So if prerequisites are met, we can start taking a course. We can do any number of courses at a given time, right? So for example, here as 1 and 2 both do not have any prerequisites, we can start both of them at the same time, right? What you need to find is you need to find the minimum months to complete all the courses. Is the question clear? What the question is asking to do? If it is clear, can you type in yes? Everyone? So let's probably take up some examples, right? So let me just go over to a screen. Okay. So let's say we have three, one, two, three, four courses with me, right? Let's say this one takes 2 months to complete, this one takes one, this one takes three, this one takes three. Okay. And let's say we have these prerequisites. So 1 is a prerequisite to both 3 and 4, 2 is a prerequisite to 4. Okay. Help me out. Help me calculate how much time will it take to complete all the courses. How much minimum time it will take to complete all the courses. एक बार सब ये केस ट्राई करोगे क्या? Can everyone try out this case? If you can find the total time needed to solve all the courses or to complete all the courses. 5. Okay, so let's see this in action. Course number 1 will take 2 months to complete, right? Course number 2 will take 1 month to complete. Okay, tell me one thing. Do I need to wait for one of them to complete to start the other, or can I start both 2 and 1 at the same time? What do you think? Can I start both 2 and 1 at the same time, or do I need to take them one after the other? Same time, right? So I'll start them same time. So 2 will complete in 1 month. Now, can I start some other course also? Can I start some other course? Now 2 is complete. Right now, no, we cannot. But if this edge was not there, then we could have immediately started 4. We do not need to wait for 1 to complete. We could have immediately started 4, right? But right now we cannot. So we'll wait for even this to finish. So we have 2 months now. And then since both of these are done, we can start them together. So plus 3 to complete both of them. So 5. Is this example also clear to everyone? Ki how we are calculating it? Yes, no? Everyone? Okay, perfect. Let's go ahead. Let's try to find a solution of this. Anyone who can think of a way to solve this particular problem? Anyone who can think of a way to solve this particular problem? Topological sort, okay. But how? How does topological sort come into the picture? DFS, okay. Okay. Tell me one thing. Tell me one thing. For any course to complete in minimum time, can we easily see a formula to calculate that? So let's say there is a course number X which has some prerequisite. So let's say there is a course Y1 which is a prerequisite. There is a course Y2 which is prerequisite. Y3 which is prerequisite, right? So let's say this course completes in 2. This course completes in 3 units of time total. Like whatever its previous parents are, they also have completed by this time. And let's say this one completes in 4. X itself, individual course, takes let's say 1 unit to complete. So can you calculate the time taken for X to complete, like everything to complete till X? तो मैंने ये बोला कि लेट्स से y1 तक सब कुछ completes in 2 units, 2 months. Y2 तक everything completes in 3 months. Y3 everything completes in 4 months, right? So how much time will it take to complete everything till X? Can I say the answer would be maximum of these 3 plus 1 unit for this, which is 5. Is this making sense to everyone? Yes or no? So if any particular course has some multiple prerequisites, the time taken to finish everything till them, maximum of it plus 1, plus the time taken to complete this particular course, that would be the answer. Does everyone agree to this? Yes or no? कि आंसर कैसे आ रहा है? Everyone? ठीक है. So now we know how to find answer for any node. So before finding answer for a particular node, I need answer to its prior nodes. This leads to what? I need to solve for the nodes in a particular order. And what is that particular order? The prerequisites should be solved first. Yes or no? Prerequisite पहले solve करने होंगे. Prerequisite का answer पहले निकालना होगा. And then you can find the answer for the next ones. Does everyone agree to this? Yes or no? Can I get a yes from everyone if this makes sense? First you find the answer for all the prerequisites, then you find the answer for this one. So this directly leads to the idea of topological sort. कि भाई topological sort, what it does, it arranges the node and gives you a particular order where the prerequisites of any node will be prior to it. So वो पहले calculate होंगे, फिर ये calculate हो जाएगा. Does that make sense? Yes or no? That how did we arrive at the idea of topological sort? Yes, no? Everyone? ठीक है. So how to do it? How to do topological sort? So let's take an example again. So 1, 2, 3 directed. Let's say this is 4 from both sides. Let's say this goes to 5, this goes to 6, right? And let's say this also goes here. Great. So let's say this is our graph. Okay. So which is the first node that we should find the answer of? Which is the first node जिसका आंसर निकलेगा? Anyone? If this is our graph, which is the first node for which we should find the answer? 1. What is the property of this node? Whose answer is very easy to calculate? Can I say the ones with in degree 0? No prerequisite or in degree 0? Yes or no? Yeah, it is समझ में आ रहा है क्या? The ones that have in degree 0, their answer is direct. What is their answer? Their answer is a direct number of months, because we can start them right at the beginning, right at 0th time, and let them finish till whatever time it requires. Yes or no? Like अगर इसको 3 months चाहिए तो 1 will be completed in 3 months. Does everyone agree to this idea? That for in degree 0 it's very easy to calculate? Yes or no? Okay. Once we have calculated for this, then in a way these two prerequisites are useless. They are already sorted. So now I can also calculate for 2 and 3. Does this also make sense? कि once we calculate the answer for one node, अब वो prerequisite खत्म हो गया, like we already know the answer for it, so we can calculate the answer for the next ones which do not have any other prerequisite. Does this make sense? Yes or no? By the way, this is also known as Kahan algorithm. It is not, Rachit. जो मैं explain कर रहा हूँ वो ही topological sorts algorithm is also the same, which is Kahan's algorithm, which says you start with the node whose in degree is 0, right? Now when you have visited it, that means the ones connected to it can be assumed to be free in a way. Does this make sense? कि जब एक बार इसके लिए आंसर निकल गया तो these edges are in a way now no longer existing because that prerequisite is done. So now 2 and 3 are free and we can calculate for them. Does this make sense? ठीक है? So let's calculate for 2. Let's say 2 के लिए number of months were, let's say 4. So 2 का आंसर क्या आएगा? 4 plus 3, 7. Does this make sense? How did we calculate for 2? 2 से पहले जो prerequisite था that was completed in 3. 2 is 4. So 4 plus 3, 7. Yes or no? Now when 2 is done, which node is free? Can you tell me? 2 के लिए आंसर आ गया तो which node is free to calculate the answer for? 6. right? 6 is there. Is 4 also free? क्या हम 4 को free मान सकते हैं? Is 4 also free? Yeah, 3 was already free, but is 4 also free? Answer is no. So a node is considered free only if all its in degrees are reduced to 0. So any node which was basically coming into as an in degree, if that node is done, all those nodes are done, then only this node can be considered as free and we can calculate the answer for it. Does this idea make sense? How does Kahn's algorithm work? So basically what you do is, you start with the nodes which have in degree 0. You visit them. When you visit them, you look at their edges and reduce the in degree of their connected nodes by 1. कि यार 2 की in degree अभी तक 1 थी, ये edge हट गया अब because I have visited 1, so I can reduce it to 0. As soon as you reduce someone's in degree to 0, it is a free edge, a free node, sorry, and it can be added now into the queue of the ones for which we can calculate the answer. ये समझ में आ रहा है क्या? How Kahn's algorithm work? Yes, no, repeat. I can repeat it again. एक बार थोड़ा clean करके. Let me just clean it a little bit. So basically what I'm saying, let's calculate in degree of each of them. So इसकी in degree कितनी है? 0. How much is the in degree of 2? 1. How much is the in degree of 3? 1. 4's in degree 1 and 2. 2. 6 in degree just 1, which is 2. 5's in degree 4 and 6, so 2. So I'm saying we start with the node of in degree 0. We calculate the answer for it. Now the nodes connected to it, for them we reduce the in degree because ये prerequisite अब खत्म हो गया है. So in a way, the next two nodes can be freed of this prerequisite. Does this make sense? That why we reduced in degree of both 2 and 3 by 1? Yes or no? We started with 1, जिसकी in degree 0 थी. We calculate the answer for it. So this prerequisite is done. So all the nodes that were connected to it, we reduce their in degree by 1, saying that because the prerequisite is done, we can ignore that for these now, right? So again, 2 and 3 become free. We calculate for 2. When we calculate for 2, we free its children. So 6 we free, it becomes 0. So 6 is also free now. 4 we reduce, it becomes 1. So 4 is right now not free. But once we calculate for 3 also, this 4 will also become free. Does this idea make sense? Ki basically, you visit something, you reduce its connected nodes in degree by 1. If it becomes 0, then you visit it also by putting it into the queue. Does this idea make sense? कि कहांस कैसे चलता है? Yes, no? And how it gives topological sort. So सबसे पहले 1 collect हो जाएगा. फिर because of 1, we'll reduce their in degree 2 and 3. तो 2 और 3 collect हो जाएंगे. Because of 2, once we visit 2, we'll reduce this 6 by 1. So 6 भी collect हो जाएगा. Then once 2 and 3 both are done, 4 will also get collected. And finally 5 will get collected. And this is how we'll calculate the total. Okay. So let's see this in action in form of code as well. So let me move to code. Okay. So I already made a submission. I think I can take it from there. Okay. So let's look at the top level steps first. First thing that I did, I calculated in degrees of every element. Does the first line make sense? अभी इस function को explore करते हैं. First line, we need to know in degree of every element. Yes or no? Do you agree? We need to know in degree of every element. So how do we calculate in degree of every element? We look at the relations. 1 is a prerequisite to 3. So 3 in degree becomes plus 1. So that is what I have done. I have iterated on the relations. So let's look at the function get in degrees. So I create an in degree array with all zeros. I go over the relations, check the second element and increase its in degree by 1. Does this code make sense? कि how we are getting in degree of every element. Just go through the relation. 3 का एक prerequisite है तो 3 plus plus 3 is prerequisite is there तो 3 plus plus right. यहाँ पे भी अगर देखेंगे तो 5 plus plus 5 plus plus 5 plus plus 4 plus plus and 5 plus plus right. So simple idea. Just look at the second element. There is a directed dash from first element to second element, so second element has plus 1 in degree. So that is what I've done. Taken the second element, did in degree plus plus. Does this function make sense? How we are getting the in degrees? By going through the relations? Yes, no? सब लोग let me know with a repeat or a yes if this makes sense. How we are getting in degrees? Okay, Anish says yes. बाकी लोग right? Fairly simple. One base indexing graph. Yes. So graph is one base. That is why we have to take n plus 1 here. Because our values are from 1 to n. So we have to take n plus 1 here. Right? So that is there. Okay. So simple. Getting in degrees. Next thing that I did. So first I got in degrees. Next I got the graph as well. Graph भी बना लेते हैं. Because when we visit something, we would need to check its edges to reduce the in degree. Do you remember that? है ना. तो एक ग्राफ बना लेते हैं. So I have written a get graph. So let's look at get graph. Get graph क्या करता है? It will make a map from, for every node, what is the list of connected nodes. So a simple map from node to its connected nodes, right? So simple, iterate on the relation. First element dot pushback second element. Graph भी clear है. You can use vector of vector if you want. Vector of vector, but I have used map just because I want to access based on a particular key. So I found map to be easier, right? So if you want, but you can take vector of vector. The intuition was easy, but the implementation is tricky. Not really. If you divide it into right functions, it should not be easy. So right now we have written just two functions: get all the in degrees, get the entire graph. So are these two functions clear? अब ग्राफ तुम कैसे भी बना सकते हो. If you want vector of vector, your wish, whatever. But using these relations, you need to create a simple graph that okay, 1 is connected to these, 2 is connected to these, 3 is connected to these. So adjacency list. Does this make sense? What the second function is doing? Getting you the graph. Right? So simple करा है. Relations पे loop लगा के relation first dot pushback relation second. Okay. Last function now. So we have the in degrees, we have our graph. Now we need to find time to complete every course. So let's look at that function, time to complete every course. So इसके लिए मैंने क्या बोला था? We'll take a queue, we'll put the elements that have in degree 0. So that is what I've done. I've taken a queue, I've iterated over all the in degrees. Whichever have in degree 0, we pushed it into the queue. Was the first line in get graph function mandatory? What the first line in get graph function mandatory? You mean unordered map? You can use vector of vector if you want. मतलब that is perfectly fine. Graph होता क्या है? Adjacency list, right? That 1 is connected to these, 2 is connected to these, 3 is connected to these. Yes or no? That is what a graph is. An adjacency list. Line 15. To make it empty. Not sure. मतलब I prefer to do it this way so that there are no weird issues, right? If you're talking about this line, I try to do so because what happens if you do graph of something dot pushback directly, I think it will automatically initialize it to empty vector. But just in case, just to be safe, I try to do it, right? Yeah. Without it also it will work, right? I agree. Because when you do graph of something and it is not there, it will automatically assign an empty vector there, right? Yeah. So that will also work. But I generally try to keep it safe because I already know there will be n values. So let's just put it there, right? Why to face any kind of weird issues. Okay, great. Last part, time to complete. Let's look at the get time completion function. So what I've done here, as I said, created a queue. We'll start with all the nodes which have in degree 0. So if in degree of something is 0, just push it into the queue. Second, I'm creating a TTL array, which is basically the time taken to complete each of the courses. So I'm saying the current node's time taken is essentially nothing but time of I minus 1. Why I minus 1? Because first node ka time is in 0. So it is written in the question that time of I represents the time to complete I plus 1th course. So this is a slight difference here कि time of I में I plus 1th course का दिया हुआ है, right? So basically when you want to access it, you have to do minus 1 to actually get the correct time. Does this make sense? First step में क्या किया है? So all the nodes that have in degree 0, they are like the starting nodes. So उनको we have pushed it into the queue. We have set their time to their actual time, right? That is this first part. ये समझ में आया क्या? Yes, no, everyone? Taken a queue, pushed all the elements with 0 in degree, and sort set their time already, right? Didn't get the line 28. So I could have done TTL of I equal to directly time I minus 1. If that makes more sense to you. Okay. Now it's fine. Basically nothing. ith node's answer is their time directly. There is no prerequisite to any node. So uska answer to usi ka time hoga, right? I've just taken max with 0. So it would not matter actually. So if you even look at the actual code that I written, it's just max with the same value. So it's fine, right? Why I have done this? Because आगे भी max use होगा, right? So I kind of probably copied it and put it up. Okay. Anyways, so now what we want to do? We want to take an element out every time, check its connection, reduce that in degree. If their in degree becomes 0, calculate their answer and push it into the queue. So let's do that. So what I have done, while queue is not empty, take an element out, right? So take the front element out. Now go through its connected elements, reduce their in degree. If their in degree becomes 0, push it into the queue. यही कर रहे थे. कोई node है that was 0, so we take it out, we check its connections, reduce their in degree. If their in degree becomes 0, push it into the queue and update their time. So update the time of this node as maximum of whatever time is there in it and the time of its parent plus the time to complete this course. ये वो maximum लेने वाला part है. Why we can't use the given time vector? We are using the given time vector only. Just you mean उसी को update कर दो? Is that what you are saying? Not create a new TTL array, but just update the original time vector. Is that what you are saying? I don't think that should be an issue, right? Honestly, because once we complete a node, then only we move on to the next nodes. So I think that should work fine as well. Actually, in सब चीजों से बस the thing that happens is that the code becomes a little unclear and unclean that what is happening, right? So those thing happens by using the same vectors again and again. But obviously time and space saves. So it's a good idea only to do that, right? So simple idea. Take an element out, check its neighbors, reduce their in degree. If their in degree becomes 0, push it into the queue. Finally, update their time. Okay, we can remove this. And I have returned this time vector back. So I calculated time for every node, returned it here, and finally I'm just returning the maximum out of it. Is this making sense? Ki how the code is working? So 4 parts: get the in degrees, get the graph, then in degree 0, push them into the queue, take an element out, check its neighbors, reduce their in degree, right? Take an element out, check its neighbors, reduce their in degree. If in degree becomes 0, push it into the queue, update their time, get the time vector back, and return the maximum out of it. कोड समझ में आ रहा है क्या अच्छे से? What is happening? Yes or no? Everyone? If the code is clear? Okay. Great. So yeah, that was the question. Uh, so in graph question, the thing is that there is yeah bit complex. So as soon as there is a introduction of graph, the question automatically becomes a little complex, right? So that's perfectly okay. The only thing with the graph questions is that there is no as such brute force. For example, what brute force would you do in this, right? You have to do a BFS. There is no other way, right? So these kind of questions are a little uh, more on you should know the algorithm kind of questions, right? But yeah, anyone who doesn't, good idea to quickly go through graph, revise graph, right? Okay. How will we do it using DFS? So DFS topological sort is slightly different. This is BFS topological sort. DFS topological sort, what it does is it uh, starts at any node, visits everything below it, keeps on pushing it into a stack, right? So finally, the last element to be pushed is the one in the top. That is the kind of idea of DFS wala code. You can read about it. Actually, DFS, the problem is you have to create the entire graph, right? Here with BFS, we did not actually need to uh, uh, we need to create a graph, but we did not need to basically iterate on it directly, right? And then follow the then calculate the topological sort, then apply DP on the topological sort. So a few steps were reduced because we could actually do topological sort and the DP part directly here in the same piece of code, right? Okay. This is dynamic programming, right? This equation that you are doing, that to calculate answer for a node, you need to take the parent nodes, their answers, and use it to update the current answer. This is DP. This is exactly what DP is, right? Return STL. Yeah. So star max element, this is a common function, min element, max element. If you don't know it's good to add it to your arsenal, right? So yeah. What else is anyone asking? By DFS, can we do taking all route and return max? I think DFS में you will have to first calculate the topological sort. पहले तो topological sort को एक array में डालोगे. Then what you will do, you will calculate the answer for each by going to the previous elements. उसमें graph को revert करना पड़ता है. And then you go to the previous element, find their answer, update the current answer, right? So in this particular question, the DFS based topological sort did not seem like a very you can say implementation wise correct idea. It will work, but it will not be as clean and as clear as probably this one, right? So that is why I went ahead with this. Okay, perfect. So great. I think we can pause here. By the way, this week I think we have two events. One event is related to resume making. So you or any of your friends, if you are finding it tough to get your resume in a good fashion, so we'll be having that. Second is we'll be teaching how to write your own microservices for a Quora kind of application. So building a live project on Saturday. So tomorrow and day after, we have two live events on the closed group, on the community group. So if you are there in the community group, you will get the links tomorrow and day after. Sorry, tomorrow is Thursday, so Friday as well as Saturday, right? So see you there in these webinars as well. It will be good if you can call upon your friends as well, right? Great. I am not in the forum. Check the description of the video. You will find a link to the community group, right? So you can join the community group, and there we keep on having these closed events as well, right? Yeah. Okay. Great. Just look for Prime Pathshala anywhere. You will see one or the other post regarding community. Find me on LinkedIn. Find Prime Pathshala on LinkedIn. Find us on Insta. Anywhere you'll find the link. Right. Okay. Great. So we'll pause here. Okay, everyone. Bye bye. See you tomorrow. Acha, time and space is left. Sorry, my bad. Time and space complexity. Anyone? Lastly, time space बता दोगे क्या? Yes, Soil, we can do that. We can do that. So I'll try to have one or two such sessions. The problem was last time we had a recursion session. The attendance was a little low, but we'll try it again. Yeah, V plus E. Very good. So both time and space is going to be V plus E, right? Okay. So great. It's very clear. Like most of the graph question have the same. When you create a graph, it automatically takes V plus E space. Here also you have the graph, you have the in degree which is V, you have the Q, you have the TTL, all of them taking V time, right? So V plus E. Uh, Similarly, the time complexity also remains the same. I know the time is V plus E for topo sort, but I cannot visualize it. Can you please tell how it is V plus E? Sure, I'll tell that. So see, whenever you are doing a traversal on the graph, let me just go back to scene 2. Any traversal, DFS, BFS, topological sort, whatever, right? So whenever you are going and doing a traversal on a graph, let's see what happens. You start here, you iterate on its children, visit this, visit this. Then you look at its child, visit this. Let's say DFS. We start here, we go left, we go here we go here, from here let's say we go here, from here we go here. So let's say I took this path. This, right? Now, do you see? I'll try to go back here via this edge and see visited and then come back saying कि ये path is not valid. Yes or no? This is what happens, right? You start somewhere, you go to the next, 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 right? And still try to go to the next. If it is visited, then you say I don't need to go there. यही होता है ना DFS में या BFS में या anywhere, right? So you are trying to go here, but you cannot, and then you come back. Then you will backtrack, then you will try to go here also and come back. So basically, in a way, you try to go through every edge once, see if you can go there. If not, then you come back, right? So in a way, you'll always be visiting the total number of edges, like every edge once. ये समझ में आएगा कि E कहाँ से आ रहा है? That you would be going through every edge once. Yes, no? दयाशंकर कल पूछे परसों पूछ लेना इस सेशन में राइट डू कम टू दी सेशन डू आस्क दिस क्वेश्चन so we have helped a lot of people who did not have BTech so it's possible तो उस पे बारे में बात कर लेंगे ठीक है is because of this second could be that let's say you don't have much of edges let's say ऐसे है graph there are only a few edges then also you will go through every node once so V भी जरूरी है in some cases it might happen that E is very less there are only a few edges but because you will iterate on every vertex and at least try running DFS from it so you will be visiting every vertex as well तो इसीलिए V plus E आता है does this make sense that which like V plus E का मतलब क्या है maximum of V and E right so ऐसे ही लिखते हैं ना DFS को for I equal to 1 to N called DFS of I this is what we do you agree for I equal to 1 to N called DFS of I so this is V in DFS you are visiting every edge once in total ये समझ में आ रहा है क्या V plus E कैसे आता है okay yeah so that is the whole idea why don't we use max VE instead of V plus E to be more clear max है नहीं ना यार वो ऐसा like the way we are writing it shows V because एक बार तो V करेंगे ही plus we are doing this DFS so E by the way there is no difference between V plus E and max V है ना won't only E do मैंने ये बताया ना केस let's say there is no edge 0 edges but 10 vertices. So O of 0 थोड़ी बोलोगे, right? You'll go through every vertex once. Yes or no while doing DFS. Okay, right? Great. Okay, everyone, then. Bye bye. I think we'll pause here. See you guys tomorrow with the new problem. Graph के questions आ रहे हैं ज़्यादा. So I'm expecting similar pattern to follow tomorrow. So yeah, see you guys tomorrow. Bye bye.